same gradient. That's why m1 equals m2. And lines that are perpendicular, the product of the two gradients equals -1. That's what that means there. m1 times m2 equals -1. Or you can say one gradient is the negative reciprocal of the other one. Sometimes you'll see that formula by just making m1 the subject. m1 would equal -1 over m2. So to prove two lines are parallel, you have to show that they have the same gradient. And to do that, remember yesterday how we were looking at equations of straight lines and we had some equations which were in gradient intercept form, y equals mx plus b form? When a line's in that form, then you can tell what the gradient is, because what's the symbol for gradient? M, yeah. So when it's in y equals mx plus b form, whatever the m is, whatever number's in front of the x, then that's the gradient. So for this question, if we rearrange this equation to make y the subject, then you can see what the gradient is. And same with here. Close. Not quite. So if we move the 2y over here, we'll have 5x minus 1 equals 2y. And then if we divide by 2, we'll get y equals that. Can you see what's the gradient of this line? What's m1? Yep, m1 is 5 on 2. You can see how the equation of this line is in the form y equals mx plus b. There's the gradient 5 on 2 and the y-intercept is -half. So similarly, you can do the same thing for this second line. You can move the 2y over to the other side and then divide everything by 2, sorry. And you can see there m2 is the same as m1. So therefore m1 equals m2. Therefore line 1 is parallel to line 2.
Was that the right therefore thing?
Yeah, it's all through.
Like that.
Yeah.
Is that how they L's?
L, yeah. Running, L. Otherwise it looks like 1. So I try and do my L's. I tell it. I try. They're both not. They both don't look the same.
Wait, how did you do this? How do you have 5x minus 1?
Then I divide everything by 2 to make y the subject.
Alright.
And I swapped it.
Okay.
Because then it's in y equals mx plus b form. Yeah. Alright, so in this next example, find the equation of a straight line parallel to that line passing through this other point. Alright, so if our lines are parallel, then you know that the gradients must be equal. So whatever the gradient of this line is, must be the same as the gradient of the line that we're trying to find. Gradient of the, yeah. So what is the gradient of this line here? 2, yeah, you can make y the subject by moving the y over here. See if we move the y over there, and it's in y equals mx plus b form. And there's the gradient. And 1 equals 2. Yeah? So because our lines are parallel, that means m2 must also equal 2. And now we've got our point and our gradient. So remember that formula yesterday I said is essential, the point gradient formula. That's the one that we're going to use now to find the equation of this straight line. We've got this gradient and we've got the point that it goes through. That's y minus y1 equals n outside x minus x1. 2 minus 2. And we want to put our equation in general form. So remember, in general form, the x term goes first, then the y term, and then the constants. In general form, there's no fractions and the coefficient of x is positive. Sorry, no.
How did you find that M2 is 2?
See, because it says they're parallel. Parallel lines have the same gradient. Any other questions? Let me know when I can change slides. Yeah? Did you have any questions about any of those lines we're working out? Yeah?
Yeah.
Which one?
Sort of.
Okay, so we're trying to find equations of a line which is parallel to this line.
Yeah.
So if the lines are parallel, that means their gradients are equal. So we first found the gradient of this line by rearranging it, making y the subject. So that's in y equals mx plus b form.
Isn't it 2 and anyway?
Yeah.
2 is just x.
No, so the gradient's always in, it's got to be in y equals mx plus b form to see what the gradient is. And then you can see there as the gradient because y equals mx plus b. So if the gradient of the first line is 2, means, and they're parallel, it means the gradient line we're trying to find must also be 2. And if it goes through that point, and that's its gradient, we can use the point gradient formula to find the equation. Yeah. Any other questions?
Is it a bit confused? You know how
Yeah.
you moved across the negative y? How can that be positive?
Oh, because the formula is y minus y1
Yeah. But then,
and y1 is negative. Equals
Okay,
n, that's like x minus x1.
okay. Because back there, wasn't it negative 2 minus when you transfer?
Oh, that's a different question. So I moved that term. Oh,
Oh,
here I was just moving stuff around. Here I was substituting in. That's okay. Alright, next question. So similar thing but with perpendicular lines now. So this next question we have to show that these two lines are perpendicular. So we're going to use the property of perpendicular lines that you just wrote down on your formula sheet. With perpendicular lines, m1 times m2 equals negative 1. So that means the product of the two gradients equals negative 1. So we have to find the gradient of this line and find the gradient of this line and then show that when you multiply those two gradients together, the answer is negative 1. So to find the gradient of the first line, we'll rearrange it to put it in y equals mx plus b form. And to do that, we've got positive y here, so means we've got to move the 3x over, and move the 11 over. So what's the gradient of this line? Yep. So m1 equals -3. We'll do the same thing for this line. Make y the subject. So we can move the 3 over there. And then we have to divide by 3. So what's the gradient of this line?
Third.
Yeah, so m2 is a third. Alright, so then we'll go m1 plus m2 equals -3 times a third, and that equals -1.
How come x over 3 is 1 over 3?
Because x is 1x.
Okay.
You can write the 1. Yeah. So if the product of the two gradients is -1, that means the lines must be perpendicular to each other. So therefore, line 1 perpendicular to line 2. Connection.
Oh, so if you can't fit it together,
Yeah, I guess they just
and then equal -1,
How do I get the simple?
So we'll work for all perpendicular lines that the product of their gradients is equal to -1. Or can you see how when you compare these two gradients, see how this is the negative reciprocal of this, and this is the negative reciprocal of this. That's another way you can think of gradients of perpendicular lines. They're the negative reciprocals of each other. Any great questions about that example there? Alright, so let's find the equation of a line then. Equation of a straight line, it goes through a point that's perpendicular to the line that passes through these other 2 points.
Tricky.
We'll set this right here. I'm not sure if you hear the understand when I said you don't have to copy these down. You hear the understand?
Yeah, but are we copying all this in now?
You can choose. Because I'm recording it. You can play back. It's up to you. You prefer to. Okay. Okay, so what we need to do here, our plan of attack will be to find the gradient between those 2 points. Yeah, now because it says the equation, the line that we're trying to find is perpendicular to the line that goes through these 2 points. Once we've found the gradient of this, we'll call that M1, and the gradient of the line we're trying to find will be the negative reciprocal of that, and then we'll use the point gradient formula with that point and our new gradient. Sound like a good plan? So let's find M1. Just the gradient formula, the gradient between these 2 points. So 7 minus 3 over -1 minus 3. So 4 over -4 and -1.
Yeah.
Yeah?
Yeah.
7 minus 3 is 4. Yeah. So our first gradient is -1.
How do you know to use the gradient formula for?
Because it's talking about perpendicular
The
lines.
reciprocal.
Perpendicular means we need the gradient.
Yeah, but how are we going to find the gradient of the straight line? The other line we just
That line?
Guarantee it's gonna be
Cool, so
one.
now that we know that the line we're trying to find is perpendicular to this line, and we know that perpendicular lines, their gradients multiply together to equal -1.
Yeah.
That means the gradient of the line we're trying to find must be positive 1. Yeah.
Is that because the reciprocal of -1?
Yeah, exactly. So M2 equals positive 1. Because M1
Yeah.
times M2 equals -1, and M1 is -1. So M2 must equal positive 1. Yeah. So now we've got our gradient of the line we're trying to find, and we've got our point. So now we're going to use the point gradient formula with our point and our gradient. Remember the point gradient formula, y minus y1 equals m, that's like x minus x1. So that's on your formula sheet. That's an absolutely essential one that you'll need both for this topic and a couple other topics to come in the future.
This M, what's that? Is that -1? This M?
No, m is the gradient of the line we're trying to find.
What's that help you find? Point gradient formula?
Find the equation of the line, which is what we're trying to do. We're trying to find the equation of the line. Yeah. So our equation will be y minus 3 equals 1 outside of x minus 2. So we've got x. Move everything over to the right hand side for general form. -y. What?
Can you go to the left hand side?
Like, should it be left hand because X has to be positive?
Yeah, it's positive on the right hand side. If we move x to the left hand side, it'll be
How
positive.
do you do that again?
Oh, does X have to be positive?
Yeah, the coefficient of x is going to be positive.
Combine
going
his
on.
head.
How did I do what, sorry? This?
Yeah.
So just substitute into this form the point gradient formula.
Yeah.
The gradient's 1,
Yeah, yeah,
which
yeah.
is 3. Okay.
And how's that simplify to 0?
And now I'm going to move the y over here, and I'm going to plus 3 over here. Yeah. Plus
Yeah.
But how, I thought, how's you got 1 for perpendicular? I thought it's -1.
Yeah, so that's the line, these two lines are perpendicular. So the gradient of this line is -1,
Yeah.
and the gradient of the line we're trying to find is going to be the negative reciprocal of that.
Yeah. I get it.
Cool. Any other questions? Okay. Yes, Matt.
If we made X -0 on the other side,
0 horizontal line. So if you got a horizontal line, then perpendicular line would be vertical, and it wouldn't have a gradient.
so you get it wrong if you did in the exam if I wrote 0 on the other side.
Oh, right. Okay, so you mean this? X minus y plus 1 equals 0? Or do you mean negative x plus 1 minus 1 equals 1?
Yeah, if you
Yeah,
swap it
that would
around.
be general form. You gotta make sure that the coefficient of x is positive.
X plus y.
So I'd get it wrong if I did it.
Yeah, you know on the formula sheet, it says in green, next to the general form, it says where a is greater than 0. A is the coefficient of x.
So then is it now y equals,
Yeah? Especially if the answer, if this question says put your answer in general form.
what do you make the now, so y is
You leave the answer in general form.
They'll push you
like that?
How'd you
You
do that? What should have won?
can leave it in any form,
Oh,
but
done.
that's just generally what you
This
do.
little lost all that.
Sometimes it's specified to leave it in general form. Alright, now quick recap on term 1, or maybe it was term 2, simultaneous equations. Remember simultaneous equations, either substitution or elimination methods? It's coming up again. Now, to find the point of intersection of two lines, you just have to solve them simultaneously.
Oh, yeah.
They will cross over each other. Yeah?
Are we doing this now?
Yeah, we're doing this now.
Miss, can we have a recap on simultaneous equations?
Yes, so that's what we have to do.
So,
So, simultaneous equations. Two equations there. Want to find the point of intersection? You could use either,
Times 2 at the top, 3.
Yeah, you could do that with the elimination method, or you could do substitution method and make y the subject in both. I
Well,
prefer
usually the easiest
substitution method. Yeah, otherwise there's too much multiplying with that other method. But do you want to try that method? And we'll see if we get the same answer. You should get the same answer. Alright, so I'm going to do the substitution method though. You can either make x or y the subject, doesn't matter. Maybe I'll, this one here, I'll make x the subject. 5x equals 2y plus 13. So x equals 2y plus 13 all over 5. Do the same thing over here, make x the subject. 3y plus 3. So x equals 3y plus 3 all over 2. Okay. Now, this equals x and that equals x. We'll say they're both equal to each other. So, 2y plus 13 over 5 equals 3y plus 3 all over 2. Because they both equal x, yeah? Because they're equal to each other. And now we're solving this equation for y. So we have to cross multiply to get rid of those fractions. And expand the bracket. And then you want to collect like terms. Minus 4y. Minus 15.
Oh, Mr. Wait.
Sorry. And divide by 11. So y equals 1. Remember how I said basic arithmetic and algebra was the foundations of it? Sure does. You can see that again. You can see it again. It comes up again. Alright, so now we've got y, we just have to find x.
Oh, yeah.
And we can find x by substituting y into either one of those. You should get the same answer. So I'll just sub it in here, I guess. X equals 3 times 1 plus 3 divided by 2. So that's 6 divided by 2 is 3. So our point of intersection is going to be 3, 1. That's the x coordinate. And that's the y coordinate.
Miss, what happens if you found out the y instead of x?
That's okay, then you substitute it back in. You get the same answer. Cool. Awesome. So if you prefer the elimination method, stick with that. You'll get the same answer. I just like substitution method because when you're trying to find the point of intersection between, say, a straight line with a non-linear equation, like a parabola, an elimination method doesn't work. You've got to use substitution. So I just use substitution for everything. Alright. Any questions about the simultaneous equations? That's okay. Yeah, Luke.
Because they're both equal 0 in the beginning, you just do straight up.
Oh yeah, but then you have two variables.
Oh, okay, yeah.
Yeah.
Okay.
Actually, yeah. What do you mean?
Because if you say both equal 0, some of x minus 0 and minus 3.
Oh.
And then you both get
Yeah, so you try to do one. Right. Cool, so now there's this new word here in this last example, concurrent. And that just means that these three lines all go through exactly the same point. So now we've got three lines. Here's the first line, the second line, and here's the third line. So to show that they all go through the same point, what you do is you find the point of intersection of two of the lines, and then you substitute that point of intersection into the third line. Whoops. And if it satisfies the equation of the third line,
Y.
then it lies on that third line. So concurrent means lines that go through the same point. So to show that these three lines are concurrent, we want to find the point of intersection of two lines by doing simultaneous equations, just like we did in the first one. And then we're going to substitute that point of intersection into the equation of the third line. And if
It makes sense.
it makes sense, yeah, that means it lies on that third line, which means that third line also goes through the point of intersection. So therefore, all those three lines are concurrent. Make sense?
Yeah.
Yeah? So, first step is to find the point of intersection of two of the lines. You can choose whichever two you want.
What would be the easiest one? First two.
Yeah, I'll just
Should you find? Should you got X and Y by themselves?
yeah, you can do that.
You have X and Y by
So let's do the first two. Alright, so simultaneous equations with those two equations, because we're going to find the point of intersection of those two equations. So, same way as what we did up here. Okay, so we'll make x the subject again. 3x equals y minus 1.
Yes. One.
Yeah, we move that across and that across. Change the sign. So then x equals 1 minus 1 all over 3. And for the other equation, got x equals minus 2y minus 12. Can we explain that again?
No, that's right.
No.
Yeah, good. And now they both equal x. Say they're equal to each other.
Oh, yep.
Yeah. So y minus 1 over 3 equals negative 2y minus 12. We have to bring the 3 up. Expand the bracket. Minus 6. Yeah. And what are we trying to do? We're trying to find y. So let's move all the y's over one side.
5y
What? Wait.
negative 35. Move the one over.
Bring the
Yeah,
6
move the
over.
one over first.
Bring 6 over and then bring the y over.
Yeah, so 6
Seven
over, so it's 5y equals negative 35.
Only do plus 6y over here. 6y plus 5 is 1.
Yeah, he's got you there.
Yeah? But you're right, equals negative 35. So then y equals,
Negative 6.
yeah, y equals negative 5. Yeah? So x equals, so we're going to find x. Just substitute the y back into either of these equations for x. So x equals negative 5 minus 1 over 3.
Negative 2.
2. What's our point of intersection?
Negative 2, negative 2.
Yep, negative 2, negative 5. Negative 5. Is the point of intersection. And remember when I was explaining it over here what we had to do? Yeah. We have to sub in that point of intersection into the third line.
Okay.
That means we need to sub it in to this one here. So if our point of intersection lies on that line, then we can say that line also goes through the point of intersection.
8 plus 15 minus.
So left hand side equals
You don't
4
want that.
times x minus 3 times y minus 7. So because it says show, you've got to make sure you're showing every step of the way on substitution. So negative 8, 15 minus 7, yeah, that equals 0, which is the all those lines are concurrent.
Wait, so the left-hand side equals the right-hand side?
All three lines.
So that means this point lies on this line because its coordinates satisfy this equation of the line.
Yeah.
So the point of intersection of the first two lines lies on the third line. So that means they all go to the same point. So they are concurrent.
What's the point that they go through?
They go to
Oh, because you have to show that they are concurrent. Therefore, lines are concurrent.
What's the right hand and left hand?
So we substitute the point into the left-hand side of the equation of the third line to see if it equals the right-hand side of the equation. Okay. Any other questions? All right, that's it. That's a wrap. There's the